Hello guys, am I audible? Can you give me a quick confirmation if you're able to hear me out? Yep, yep. Okay, we'll wait for some time so that everybody joins. Yet another exciting session in LangGraph. Okay, yeah, I'm audible, I guess. Great, let me check from my end if it looks fine. Hello, Dritesh. Hello, everybody. Hello from Peru. Hi, Mario. So I'm also live in LinkedIn, so people are able to hear me in LinkedIn also. Ravi Shekhar Verma says yes. Okay, we also have people from Turkey. Great. Okay, welcome everyone. This is the tutorial third, and in this session, we are going to discuss about how to build chatbots with the help of LangGraph. Again, a practical session completely, and yes, we will also see how we can probably go ahead and implement things. Okay. So please make sure that you hit like because this LangGraph series is going to go on for a longer time. And soon we are also going to start with MCP. Again, I will be using LangGraph framework itself for doing all the necessary things itself. Okay. So yeah, I hope everybody is probably audible. You're able to hear me out. And yes, I watch lecture, but it becomes difficult to execute in code. No worries. We'll help you in that. Please do end-to-end projects. Perfect. That also I will plan. Okay. So let me quickly go ahead and share my screen. And then we are just going to start with each and everything. Okay. So just let me know once you're able to see my screen. Yeah. Hi, Krish. Manoj here from Bangalore. Hello. Thank you very much, sir. Is MLOps compulsory before learning LLMs? No, not necessary, but it is good to have. Okay. So everybody, I hope you all are ready. I hope you are able to hear me out quickly. So let's go ahead and let's work on today's use case. Okay. So here, our main plan over here is that we are going to build a chatbot. So first of all, just go ahead and write about the entire agenda, what all things we are basically going to discuss. Okay. So we are going to create a chatbot with the help of LangGraph. Now, this will not just be a simple chatbot. With this, we are going to integrate tools, multiple tools. I'm not talking about just one tool, multiple tools. And then we will try to also discuss about a React architecture. I don't know how many of you have heard about this React architecture, so that you know your chatbot will be specifically working based on this React architecture. Okay. Now, what exactly is this React architecture? This is not a JavaScript framework React. Okay, it is something else. We say this as based on reasoning and acting. Okay, so here specifically we use two terms. One is reasoning, and then you are acting. Okay. So now in this chatbot, see later on the reason why I'm explaining you this, because soon we are also going to start to talk about MCP. Okay, MCP, that is model context protocol. Model context protocol. Okay, model context protocol. And if I talk about model context protocol, here we'll also try to develop some kind of protocol how LangGraph or any AI assistant will be able to communicate with this kind of tools. Okay, but first of all, as usual, we will cover all this specific stuffs. We will implement it practically. We will try to understand each and everything with respect to this. Okay, now quickly going ahead, what we are basically going to do, what is our plan, that I'm actually going to talk about. So here we are going to create a workflow. This workflow will be nothing but it is a chatbot workflow. chatbot workflow. Now, inside this chatbot workflow, what we are basically going to do is that we will create something like this. Let's say this is my start node. This is my start node, okay, inside my workflow. This will be my AI assistant. Let's say this is my AI assistant. And this AI assistant, let's say this will be having some Grok open source models. That is what we are going to use. We are not going to use OpenAI because I hope everybody will be able to get the Grok access because it is completely for free, at least for some number of requests. And this AI assistant will will have will have the access to tools, right? So this is basically going to have the access to some tools. Okay. Now, what all tools I will try to create? We can create anything. Like, let's say I have RCIF tools, I have Wikipedia tools, okay, or I may have any internet search tool, okay, internet search tool, okay. Now, based on this specific tool, what will happen is that once I have this particular tool, that basically means when I ask a question, that the LLM will not be knowing it. Let's say that if I ask, hey, what is the current news? What is the news for this particular day? Let's say, what is the news of April 14th? What is the recent AI news on April 14th? So what AI assistant will do is that it will try to go ahead and see that, hey, what tools it specifically have, you know, and based on these tools, let's say that it is having this internet search tool. So based on this particular information, we will get some kind of response. Okay, we'll get some kind of response. Otherwise, if I'm doing any search that requires a Wikipedia search, we can also go over here. Okay, so this, once we get this specific information, then we are going to go towards the end section. Okay, end section. Now this is my entire workflow that I am going to create. This is the entire workflow that I am going to create with the help of LangGraph. Does this make sense, everybody? Yeah. Can I get a quick yes if you are able to understand it? The reason why I'm making this, why I'm showing you, because in the future sessions, what I will do is that I'll replace these tools, and in between, I'll bring a MCP protocol, and through that, you will be able to call these service providers. How we will be able to call it, I will talk about it. Okay. But here, I hope you are able to understand. Now, we spoke about something called as React architecture. Okay, reasoning and acting, right? See, when AI assistant is getting some kind of input, you know, it is basically asking this particular tools whether you have that specific output for this input, or whether you can serve that particular uh, information, whatever information the human is basically giving. Are you able to help us out with that? And one of the tool will basically give you the kind of response, right? Now here, my AI assistant is basically the brain, right? Brain, right? Here my AI assistant is basically the brain. As soon as I get an input, AI assistant will be responsible in making the tool call. Okay, tool call. This will be responsible, right? It'll be responsible because we have already integrated all these tools with our AI assistant for this specific node. For this specific node, this will know, hey, we have to probably go ahead and make the tool call. I will show you practically how do we integrate it, each and everything. Don't worry about it. Now, once it knows, hey, I need to make a tool call, so it will just go ahead and make a tool call for this particular node. So this will be also a node, and this node, I will name it as something called as tool node. Something called as tool node. So in LangGraph, you have something called as tool node. Tool node basically means it is a kind of node which is integrated with some tools. Okay, it is basically integrated with some kind of tools. So here I have multiple tools. So all these things are integrated in a tool node. So what happens is that once a request goes to this specific node, this node which has the LLM, so this node has the LLM integrated over here, it will be able to decide whether there is a tool call or not. If there is not a tool call, this will give the response and it will go to end. Otherwise, this will decide, hey, whether we need to make a tool call. So here we make a tool call based on the input. We basically call that specific tool, get the output, and give it to the AI assistant. And this is what a React architecture basically works. React architecture basically works. Okay. And I should not be naming it something like this. It should be something like React. Okay. React. Okay. Now let's say if my question is something like this, I have a tool. Okay. I'll say, hey, tell me about research paper, and I will give the research paper number. Okay. And then I'll say, hey, then search for AI. What is AI agents? Or tell me what is AI agents. Okay. So if this kind of question is there, here you can see I have two questions. First question is that I'm saying, hey, tell me about the research paper and the research paper name. So in this particular scenario, when this input goes, the AI assistant will first of all understand, hey, this is my first part of the sentence. Okay. So after seeing this particular sentence, it will think, hey, whether I need to make a tool call. Since we are talking about research paper and I've got the research paper name, I have a tool which is called as rsave. So definitely, I will first of all take this part, go ahead and hit the tools, and go ahead and hit my rsave tool and get the response back. Right? Then the AI assistant will think, hey, still there is some more input that is left. Now, what should be my next step? Right? What should be my next step? Now it is saying that, hey, what is AI agents? Now it will just go ahead and see whether the LLM can provide the response. If the LLM can provide the response, AI assistant will then provide the response. It will say that, hey, now I don't need to make a tool call. I have to probably give the answer, right? So what happens? The first context answer will be something else. The second context answer will be given by the AI assistant. And finally, this node will combine them and give it till the end. That basically means to the user. Okay. So here, React basically means reasoning and acting, right? So based on every input, this AI assistant, which is having this specific LLM, is able to think, right? And then act. Yes, I hope everybody is able to understand over here. Can I get a quick yes if you are understanding everything what I'm explaining over here? And if you like this explanation, please make sure to hit like and make sure to support the channel. At the end of the day, all these things are specifically free for you all, right? So tell me, are you able to understand what is a React architecture? Yeah. Perfect. So till here, I hope everybody is clear. Now what I will do, I will just go ahead and start writing the code. Okay. Now it will be amazing. Now previous example, we built this simple graph, simple graph over here, right? Now what I'm actually going to do, I will just go ahead and build some kind of, so I'll write 3 LangGraph, LangGraph, and I'll say, hey, tools, or I can go ahead and write LangGraph tools. Okay. So chatbot plus tools, I will go ahead and write. So here I will write chatbot multiple tools dot ipynb. Now let me just go ahead and show you everything step by step. Are you ready? Don't worry about the notes and the materials. Uh, in the description, there is a registration link where you can go ahead and just enroll it over there. I will put the code in that particular dashboard. Okay. Is everybody ready? Shall we go ahead with the code? Yeah. Give me a quick yes if you are specifically ready, and then we are good to go. Okay. Now, first of all, what I will do, I will just go ahead and create, since I'm going to use a LLM model. So first of all, I'm just going to go ahead and create my .env file. Now, inside my .env file, I'm going to use a API key, which is my Grok API key, right? So I hope everybody knows what a Grok API key is, right? So if you go to, let me just open my browser. Okay. So here, console.grok.com, right? So inside this grok, if you see, just go ahead and click on playground. Here you'll be able to see there are so many different kind of open source models, right? So we are going to use this open source models specifically for doing all the works that we have, right? Now, if you want to get the API key, just click on the API key, create the API key. I think if you are religiously following my YouTube channel, you should be able to understand how to create an API key. Long back, I've actually taught you. Okay, just go ahead and create the API key and be ready with the API key. Now, the next step is that I will just go ahead and open my file. So here I have pasted my API key, the Grok API key, which we are going to specifically use. In requirement.txt, we have written all these particular libraries. If we require any kind of other libraries, we will just go ahead and update it. For right now, let me just go ahead and update some of the libraries since we are going to also use Grok. So one is the python.env. Now, this specific library actually helps us to load the environment key variables from the .env file. The next thing is that, as I said you, I'm just going to go ahead and write LangChain dash grok. Okay. So this is also, I will be requiring it. Perfect. Now till here, I think everybody is very much clear with all the things that we have specifically done. Okay. And we will just go ahead and start our coding. And first of all, we will try to build the chatbot with multiple tools. Okay. So before I go ahead, as I said already, that here I'm going to use some different libraries like RSafe tools, RSafe Wikipedia, uh, and there may be some more additional tools based on your tools that you can specifically use. Okay, and LangChain actually provides this specific tools also. So for this, I will also go ahead and import two more libraries. One is RSafe and Wikipedia, since we are going to use these two tools. Now I'll just go ahead quickly. I will write pip install -r requirement.txt. Okay. Um, Soon I'm also going to move it to the UV package, and recently I've also uploaded a video on that. If you have not seen that, please do let me know. Definitely do check it out. It is quite faster when compared to pip. Yeah. Now let's go ahead and write our code in chat multiple tools.ipynb. Okay. Now the initial stage will be that I will first of all go ahead and create my tools. Okay, tools. Okay. Now here, the two tools that I'm actually going to use is Archive and Wikipedia. Okay. So for Archive, if you just go ahead and probably see in LangChain, I will be able to see that how do we call Archive tool. I will just go ahead and write Archive, and here you have, right? So if I just go ahead and click on this, you'll be able to see that, hey, we require this Archive over here. Okay. And here you have something called as archive loader. Okay. And how do you specifically run this particular tool? All those particular information is basically there, right? We have already done the installation of archive. So what I will do, I will just go ahead and write down the code. Again, you can refer it from the documentation. So first of all, I will go ahead and import two important package. Okay. One is the archive query run, and then you have the Wikipedia query run. Then Archive API wrapper and Archive, oh, sorry, Wikipedia API wrapper and Archive API wrapper. So this is just like a wrapper on top of that particular tool. I will just go ahead and execute this because this is what we are specifically going to use as we go ahead. Okay, everybody clear with this? Yeah, everybody clear with this? This is very much simple. I did not do any much things itself, but I feel that this is really simple. Okay. Now, once I've created this Archive API wrapper, I will basically go ahead and create a variable API underscore wrapper underscore archive. I don't know this. I will just disable my extension. Just a second. I hate this Copilot. I don't know why. Unnecessary. It will just go ahead and keep on making all the suggestion which I don't like. Okay. I don't like any kind of suggestion itself. Okay, this is my VNV. Perfect. Okay. API wrapper archive, and then I'm just going to initialize my archive wrapper, and I'm going to say, hey, probably if you are searching, just provide the top k results is equal to 2, and then the maximum number of characters that you should return is 500. Okay. So this is the kind of characters that I should be getting over here. And if I want to run it, I will just go ahead and write archive is equal to archive query run. Okay, query run with this particular wrapper, and I'll also give a description saying that query archive papers. Okay, and then I can just go ahead and print archive dot name. Now here what I'm actually doing is that I'm creating the tools first of all, right? Whatever tools I require, okay, we are just creating that particular tool. So archive is one of the tool that I have. Now similarly, Wikipedia also we have imported over here. So Wikipedia also will be one of the tool. Now let's say that if I want to use this archive to do any kind of search, how do we do it? So I will write archive dot invoke, and here I will just go ahead and write let's say I will go ahead and write attention is all you need. Let's say if I want to search for this particular research paper, now it is just going to use this particular tool and this particular providers to probably provide me the response over here. So here you can see attention is all you need, but you don't need all of it for its inference of large language model. This paper information, everything is provided over here, and the maximum characters will be 500. So that basically means my RCIF tool is working absolutely fine. Similarly, I will do it for Wikipedia also. Let's say if I want to do the Wikipedia search, so Wikipedia API wrapper, top K results 1, doc contents max is 500. And similarly, Wikipedia query run will create an API wrapper on top of it. And this will basically be my tool. Okay. Now, I hope everybody's clear with this, what we have basically done. Can I get a quick confirmation? Yeah. Please, everyone. Yes. Is it interesting? The session is interesting. I hope you are able to understand it. I hope you are able to find out things very much easily. Just let me know whether you are following each and everything or not. Okay. So just quickly, yes, it's okay. You can search for any paper that you want. Okay. You can search for RNN. Okay. What is the latest research on quantum computing? Just go and search for it. Okay. And here you should be able to get the response fast and efficient, non-volatile. These all things are there. Happy, Chetan? Hmm? I have a lot of interest in attention is all you need, but so that is the reason I usually search for all those things. Yeah. Perfect. Now my tools are ready. Now I need to integrate this in my workflow. That is the most important thing, right? I need to integrate it. Now the next thing is that I will just go ahead and import OS and call my API key. Okay. So here you can see I have my API key from load.env, load env, and then I'm importing os.environment, Tavily API key, os.getEnv. Tavily API key is just like my internet search. I'm also going to use that specific key. So for this, I will just go ahead and write Tavily API key, and let's go ahead and get it. Okay. So this search API is basically, say, connect your LLM to the web. You can basically get started. I'll just go ahead and log in. Once I log in, I should be able to get my API key. So I will continue with Google. Okay. I'll continue with Google, and this is what my API key is. Okay. So I can copy this specific API key and put this in my .env file. So I will just go ahead and go to my environment variable. And here itself, I will just go ahead and write it down. Okay. So this basically becomes my Tavily API key. Okay. Tavily API is just for my, like how DuckDuckGo search will do. Similarly, internet search Tavily API will do. Okay. And then what I will do is that I will just go over here. Okay. I will write os.environment, Tavily API key, get env, this, and we know how to import it, right? So once we do this, the next step is that we are good to go with the this. This is what I have for my LLM. I will be using the LLM. That is nothing but from the Grok, I will use one Quen model or any other model that you have. Now, since I have already imported the Tavily API key, similarly, we'll go ahead and create the Tavily tool, right? So let me just go ahead and do that. Again, in LangChain, you have something like from LangChain underscore community dot tools dot Tavily search, import Tavily search results. I have to initialize Tavily. And then once I execute this, okay, if I just go ahead and write Tavily dot search, oh sorry, dot invoke. Okay, invoke. Let's say I will just go ahead and ask some different question. Okay, provide me the recent AI news. I'll just go ahead and ask this particular question to them. Okay. So three tools. I will try to integrate three tools in my chatbot. So here you can see I'm getting all the information along with you'll be able to see that I'm also getting the link of that particular page. That is very very amazing, right? So this particular page, I'm also getting this particular link information, each and everything. Okay. I hope till here, what we have done is that we have created three tools. One is the RCIF, one is the Wikipedia, one is the Tably. Okay. And then we go to the next step. Now, in the next step, what we do, we will be combining combining all these tools in the list so that we can integrate with our LLM. Okay. So I'll just go ahead and write, hey, tools is equal to RCIF, Wiki, and Tably. Okay. So I've imported all these things. I'll just go ahead and execute this also. Okay. So this tools basically have all the list of tools, right? Now it's time we will go ahead and initialize our LLM model. So initialize the LLM model, right? From LangChain underscore grok. I'm going to import the grok LLM. Sorry, not grok LLM. It should be chat grok. Chat grok. Okay. And then I will say, hey, LLM is equal to chat grok. I'm initializing my chat grok. And here I will just go ahead and write model is equal to Quen. Let's take the recent model that is there, right? Quen 2 billion, sorry, 2.5 with 3 billion parameters, or 32 billion parameters. Okay. So this is the information that I have, and this is my LLM that I'm actually going to use. Okay. Let's say if I go want to use this LLM and just write dot invoke, I should be able to get the answer. What is AI? Okay. So this is my question. So LLM, it is giving me some error. Let's see. The model Quen has been decommissioned. Very good. Okay. So here, instead of writing Quen, let me just go ahead and see some more models. Okay. Mm-mm-mm-mm. I will say, I'll think of, okay, this model. Okay. Quen QW key 32 billion. Okay. QWQ 32 billion. Q QWQ 32 billion. Oh, Q. Perfect. So this has got executed, I think. Yeah. So here you can see I'm getting the response. Let me start by breaking. Think all this information is basically there in the form of AI message. Okay. Now you should know that, let's say if I have all the specific tools, how do we combine with our LLM? That is the most important question, right? So for this, what I will do, I'll just go ahead and write LLM dot bind underscore tools. Okay. And here we are going to specifically go ahead and specify my tools, right? Once we just write like this, that basically means my LLM will get binded with this tools. That basically means the LLM will have the information for this particular tools. Okay. Then I will go ahead and write LLM underscore with underscore tools, which is my variable. Okay. Perfect. LLM with underscore tools. So I'll go ahead and execute this, and this executes perfectly well. Now, in order to execute it, let's execute the call. Okay, what we are looking for. If I go ahead and write LLM also, what is the latest research? Or let me just change this question. What is the recent news uh, on AI? Okay, I'll just go ahead and search for this. Now here you can see one very amazing thing, very amazing thing that is happening over here. Okay, and you can just see this. Please observe on this. Okay, here it is not giving me any answer. Instead it is saying, hey, it is a tool call, and the function argument is something like this, and we are doing a tably search result. See, do you see this? It is doing a tably search result JSON. That basically means it knows now if the LLM is making a specific request based on the tools. It is basically telling that it is not directly giving you the output. Everybody, does it make sense? Yeah. So I have binded LLM with this specific tools. My AI assistant is ready. Now what I will do, I will create the entire application in my LangGraph, and my LangGraph will be doing that specific task. Does this make sense, everyone? Yeah. Yes or no? Yeah. Yes. Can I get a quick yes, everyone? Are you following perfectly fine? Is it making sense, everybody? Yeah. Can I get a quick yes? Are you following all these things? Now you can see that I'm not getting the output. Here, instead, I'm getting at something called as tool calls. Because we know that the LLM will not be able to probably answer this. Which tool it is calling? If you see further, here you can see Tably, right? Tably details is basically given, right? See, model Quen, this tool call, everything, Tably search. See, Tably search result JSON. Yeah. So this is what is basically going to happen, right? And because of this, I think you are now able to understand that, hey, my LLM is able to understand which tool to call for a specific input. Okay. Now the main aim over here is that why it is only for Tably, because the other tools cannot answer this, right? Do you think Wikipedia will be able to answer? It does not provide you news, right? Will RCIP be able to answer? If I go ahead and ask, hey, what is the latest research paper on quantum computing? What should be give me the answer? Tell me. Tell me, anyone. Anyone? What should be which tool should be giving the answer? This one. Which tool it should call? Anybody? Any guesses? Which tool should it call? If I'm asking this question, what is the latest research on quantum computing? RCIP tool, right? It is very simple. So here, now you can see tool call, function argument, quantum computing. Do you see the name RCIP? Beautiful, right? Now the LLM is able to understand, and it is able to say, hey, I know based on your input, what tool should I call, right? Now what will happen if I just go ahead and execute this particular sentence? Hey, what is machine learning? Now tell me which tool it will call. Will it call any tool, or whether the LLM will be able to answer it? There is a possibility that it may also call wiki tool, or it may directly give you the answer. So here you can see that in this particular scenario, it is basically calling the Wikipedia, I guess. Wikipedia. Yeah. And sometime what will happen is that when you keep on executing this, the LLM may also give you the answer. Okay. The LLM may also give you the answer. Yeah. Now I hope everybody is able to understand. Yes. I hope you are able to clearly distinguish that how do we bind a specific tools or provider with LLM. And here you can also bind multiple tools. Clear? Everybody clear? Let's go with the next step. Now the next step will be that I will start creating my LangGraph application now. Now I will create my entire workflow based on this React architecture that we have drawn. It should start, then go to AI assistant. We have to create all this tool node. On this tool node, it should basically have this connection with respect to all the tools. Then we have to probably go to the next step. Okay. Ready, everybody? Yes. Shall we go ahead now? Yeah. Perfect. Now we will try to create the workflow. Now you know that if you have attended my previous class, if I want to create the workflow, first of all, I will be importing some of the libraries, right? So let me just go ahead and import some of the libraries like typedict, any message, annotated, add messages. This add messages is basically called as a reducers and LangGraph. Okay. I will talk about this more as we go ahead. What is the exact usage of reducers? Annotation basically means labeling. Okay, labeling. Any message basically means it can be either a human message or AI message. Okay, so if I combine both of them, or if I combine AI message, system message, then it is a type of any message. And type dict is basically for my entire state that I'm actually going to create. Okay, so once I execute this, the first thing is that I need to define my state schema. And in the side my state schema, the messages will be the key variable that will be passing through all the nodes. Okay, now I will just go ahead and create my class state. Then this will be of type dict. Okay, type dict. And here we will be defining something like this. This will be nothing but messages is equal to, instead of writing list of, I will write annotated, annotated, and this will basically be list of any message, comma, add underscore messages. I will talk about this, what exactly this basically means. Okay. Now here you can see that I am defining a variable that will be available in every node in that particular LangGraph flow, LangGraph workflow. And this is of type annotated list of any message. List of any message basically means this will be nothing but list of all the AI and the system message and the human message. It will keep on getting appended. Now, how it is basically getting appended? Because of this particular functionality that is called as add underscore messages. This add underscore messages is basically called as a reducers. Reducers basically means what this is going to do is that it will not override inside this particular variable. Instead, it will append messages inside this particular variable. And finally, the return type will be in the form of type dict. Okay. Does this make sense, everyone? Yeah. Yes. Does this make sense? I hope you are able to understand this. Every parameter we have discussed, right? Annotated list of any messages basically means this will be a list of message with respect to the human interaction, the AI interaction, the system requirements based on that, right? And add messages. This add messages is a kind of reducers. Reducers, why? If I use some other functions over here, this messages variable will get overridden. We don't need to override it. We need to append it. So this add underscore messages, which we have imported from here, which is a reducer, it is basically appending it. Okay, clear, everyone? Yeah. So till here, if you are very much clear, then we will go ahead with our next step, wherein we will just go ahead and create our entire graph. Okay, so now I will go ahead and create my chatbot. Okay, as I said you, how many nodes we definitely require over here? There are three different nodes. One is start. Sorry, I'll not consider start or end as nodes. AI assistant is one of the node. Tool node is also there. Okay, so I have to probably create this particular node and this node separately. Okay, and then we need to add edges from start to AI assistant, AI assistant to tools, tools to probably tools, from tools to we can also end it. Okay, so we will try to create in that specific way. Okay, so here first of all we will go ahead and import all these important libraries. LangGraph.graph, import state graph, start, end. Then I am having a tool node which is a pre-built in LangGraph, and one is tool condition. Tool condition basically means when should we call the tool node. So that is the reason we specifically use tool conditions. Okay, so tool conditions over here is just like, if my LLM is calling a tool, then what path I need to take. If my LLM is not calling a tool, what path should I take? Okay, so once I execute this, these are the default things that we specifically require. Then the next step is that we will go ahead and define our node definition, the first node definition. Which one? This one, AI assistant. Okay, so for that I will be using this definition tool calling LLM. State is equal to state, and here you can see that it is returning LLM with tools. Do you remember what is LLM with tools? LLM with tools is the same LLM with tools which we have integrated with all the tools. So this is what we are calling it over here, right? LLM with tools dot invoke state of messages. Okay, state of messages. So state of messages will be having all the messages value. And as soon as we write this, you can see that we are writing this in the form of a list. And because of this particular variable add underscore messages, it is just going to append it. Okay, clear? Yeah. So this is my one node. Okay, then we go ahead and building the graph. So this we will go ahead and build the graph. So for building the graph, we will initialize state graph is equal to state. Then we are adding a node. Tool calling LLM is nothing but this tool calling LLM. And we are adding another node, which is called as tool node. This tool node, right? And this tool node is basically aligning, or we have to just pass all the tools that we have defined in our application. Okay. This is very, very simple. One is tool calling LLM node, one is the tool node, and this tools, whatever we have, we are passing it inside this. Okay. So this node is first node is tool calling LLM, and the second node is tools. Okay. I will go ahead and execute this. So this is my LangGraph with respect to this. It is ready. Okay. Now the next thing is that we will go ahead and add our edges. So first edge is from start. So here you can see from start. Just a second. So here you can see the first edge is from start to tool calling LLM. That is this one, this tool calling LLM. Then from tool calling LLM, it will first of all determine. See, this tool condition will determine if the latest message result from the assistant is a tool call. If it is a tool call, the tool condition routes to tool by default. If it is not a tool call, then the tool condition routes to end. Okay. So that is the reason we have written tools condition over here. This is my additional conditional edges, and tool calling LLM will be making that particular call, whether I need to make a call to the tool or whether I should not make a call to the tool. So my call to the tool is basically over here, and it has to probably make this specific tool call. Okay. Based on this tool condition. This tool condition is default available over here. See, it is a pre-built library, and it is basically taking up this specific two steps. Okay. And then finally from the tools, we will add this to the end. Okay. Right. So first edge is start to tool calling LLM, then tool calling LLM to tools, then tools to end. Okay. Now, if I want to probably display this graph, I will just go ahead and compile it and display it. See, do you see this, everyone? Amazing, right? Yeah. Do you see this? See, again, I'll be repeating. Okay. So first of all, what we did, we defined our node definition. Okay. Inside our node definition, I'm calling a tool calling LLM. This LLM, it is nothing but it is just invoking whatever message it is basically getting, and it will putting inside this particular messages variable. Okay. Then here you can see that I'm building a state graph. I'm adding node tool calling LLM with tool calling LLM. Then my another node is tools, which is a type of tool node, right? And this tool node tools, we are passing it inside it as a parameter, right? So it has references of all the tool providers available, right? Then we are defining our edges. Okay. Builder.add edge start tool calling LLM. Okay. Then we are adding conditional edges from tool calling LLM. If it is a tool call, directly tool condition will route to tools. Otherwise, it will route to end. Okay. So here you can see that based on this particular tool conditions, it will route to tools. And if it is routing to tool, from tool to end, we will be creating one more edge. And finally, we are compiling it and we are displaying this in the form of graph. So here you can see this particular graph from start, tool calling LLM to tools to end. Make sense, everybody? I hope everybody is able to understand or not. Yeah. I will talk about that also, prioritizing tool call LLM. MK Karthik, just a second. Everybody's clear with this? Come on, tell me, guys. Yeah, understood. Now it's time that we will just go ahead and invoke this and see whether this is working or not. Okay. So in order to invoke it, I will just go ahead and write messages graph.invoke messages human message. Let's see. If I give this particular number, what do you think which tool call it should make? This is a research paper number. This is a research paper number. Tell me. Archive, right? Now see the magic, okay? See, one thing is very important that you need to understand. When we give the input, the first input goes to the LLM. The LLM then decides which tool call to make. So here we are making one specific tool call. Okay, rsieve. Let's say it says rsieve. Then rsieve over here will execute and give you the output, and then it will go to end. Okay, now see this magic. I will execute this. Oh, human message is not defined. I have to import the human message. Just a second. Oh, it's okay. If I remove the human message also, it will work. I will just go ahead and execute this. Now see this. By default, this will become a human message only. Do you see? First of all, when I gave this particular input with respect to the human message, the AI message, see AI message, why it is saying? Because this is my AI, right? This is my LLM. See, observe this. This output is really important for you all to understand. So this is my tool calling LLM, and this is basically giving you the output, right? So the AI message says that, hey, it is a tool call, rsieve, okay? And the argument is nothing but this specific query, right? Then what it goes? It goes to this particular tool since it is making a tool call, right? So this tool is basically going to give you the output. Name rsieve, published all the information regarding this particular research paper. Yeah. So the output is basically, see, if output is coming from the tools, it is basically a tool message. Let's say if I give a message, something like this. Let's say I give a message. Hi, my name is Krish. Let's see. Now, why it is giving human and AI message? Why it did not hit a tool call? Isn't it amazing? See? Tell me which flow it has followed. I said, hey, hi, my name is Krish. It got into this tool calling LLM, and then it went to directly end. Yes or no? See? AI message, and it directly went to end. Yashwant Alamuri, if you don't know this, what you'll do with MCP? Huh? You'll play Kathakali. Hmm? Yes, Anand, you can also have your own tool. Okay? Isn't it good? See, this time I just asked, hey, hi, my name is Krish. I did not ask any questions related to any other thing. This is my human message. AI message basically says that I'm getting the response directly from the LLM. Here, we were getting tool message, and we are getting a direct response from tool. Understood? Yes or no? Now I'll ask you one question. You have to give me the answer, okay? Let's see how many of you will be able to give the answer. Hmm? I will ask you one question. Wait. Tell me, if I want to create something like this, tell me what changes I need to do in the graph. It's very big, yeah. Right. I remove this. Tell me, if I have this diagram, then what changes I have to make in the graph? Tell me. Right now, the tool calling LLM is directly calling the tools and going to the end. Now, if I need to make this specific changes, Add conditional edges from tool to tool calling LLM. Amazing. Great. Is it so? Great, 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 great. Can I just do something like this? I'll copy this entire thing. I'll paste it over here. See this. If I want to create in that way, if I just say, hey, from tools, go back to tool LLM calling LLM. If I make this specific changes, don't you think I'll get the same result? Yes or no? Okay. I have to probably execute it once again. It's okay. I will just restart my kernel and execute it. Okay. But I hope you got an idea, right? This is basically React agent only. See, from tool calling LLM, I have to call back the tools. Okay. So let me just go ahead and execute this again. Quickly. Tools, Quen. What is AI? Tools. Now, instead of calling this particular workflow, this is my dictionary. This is my this. I will just, instead of calling this, I will call this the below code that I have written. Now see this graph. LLM with tools, tool calling LLM to tool calling. Hey, why I'm getting this error? Let's see. Mermaid link. Oh, I think this is active. That is the reason I'm getting this issue. This will execute it. This is giving me an error because I have already displayed one graph. That is the reason I'm getting it. It's okay. What we will do, just a second. Add another edge to tool calling LLM from tool node. Add tool calling to an end. It's okay. We don't require. See over here, tool calling LLM to end, it will go automatically. Don't you think? Because here it shows that if the latest message for the assistant tool call conditions route to tools, right? So here it will happen that. Okay. Now see this magic. Okay. I will just go ahead and search for something like this. Now see. My name is Krish, and please tell me the. See this, everyone. Please, everybody, see me. And please, Krish, why space is not working? So let's execute this once, first of all. Just a second. I have to make some changes. I will make it. Okay. Okay. So now, if I ask this question, my name is Krish, and please tell me the recent research paper on quantum computing. Okay. Okay. I'll ask this question. Now, see how many questions I've asked. I've asked two. My name is Krish, and please tell me the recent research paper on quantum computing. Okay. Now, based on this diagram, just think like how the flow will be. Do you think the two question will be answered at a time, or one by one it will be answered? And this loop will be very, very helpful in that way. First of all, tool calling LLM will take the first context, first sentence context. and then it'll think whether I have to make a tool call or not. So let's see this. Okay, so I'm just going to go ahead and execute this. My name is Krish, and please tell me the recent research paper on quantum computing. Let's see how it will work. So first is the human message. Okay, my name is Krish. Then here you can see tool call automatically is basically made. Okay, and it is probably going and finding this, right? So this is a problem out here. Okay, the reason why it was not able to answer, and let me make this particular question change. Okay, I'll say, hey, let's say, what is the recent AI news, and then please tell me something. Okay, I'll ask this question. Let's see how it will probably give me the answer. Okay, what is the recent AI news, and then please tell me the recent research paper on quantum computing. Okay, do you see what is the recent AI news, and then please tell me the recent research paper on quantum computing. So first it made this tool call. Do you see this RCIF tool, sorry, Tavily search tool call? Yeah, and then you can see I got this particular response from Tavily, right? Then do you see I got a RCIF call? Yeah, the first thing was that it took the first sentence, what is the recent AI news, right? And it did this Tavily search. Now see, observe with respect to this particular flow. I gave a longer sentence which had two different sentences out there. One was, hey, provide me probably the recent AI news, and then tell me about the recent research paper on quantum computing. Okay, now see the magic. So first of all, the tool calling LLM is saying that, hey, I have to first of all handle this first sentence. So what it did, based on this human message, it made this specific tool call, and it got this particular output from the Travely search result JSON, right? Then this next sentence continuation is happening. Now tell me where this should request should go, whether it should go to Archive or Tavily, where it should go. Archive, right? So it made an Archive call. And finally, this is basically a response. Yeah? Making sense? Yes or no? Everyone, how happy are you with the session? And this is the framework that we have followed over there, a React framework. React basically means this will reason. First of all, a reasoning will happen, and then the acting will happen. Yeah? Happy with the explanation? And this is just one thing, because I'm thinking that in the next session I will talk about MCP also. How you can probably replace this entirely with MCP, and what are the advantages that you specifically get with MCP, right? Make sense, everyone? Yes, it traverses one tool to the other tool, right? It is jumping from one tool to the other tool. Yeah. Sir, what are the prerequisites? See, guys, again, I'm telling you, uh, for this, you definitely need to know Python programming language at least, then you should be able to understand and all this specific stuff. I will be putting all this particular code in the registered link given in the description. Either it may be in LinkedIn or YouTube. Just go ahead and see that. And if you also want to join, we are starting our batches recently. One live batch we are basically starting, which is nothing but Agentic AI. And this particular batch is nothing but, if you probably go ahead and see the course detail syllabus, like just go to krishnaik.in, click on live classes, and here you'll be able to see that live Agentic AI and Generative AI application in Bootcamp. Okay, and if you go over here, if you click on enroll now, this is the page that you're going to go ahead. So here we are going to probably take about each and everything. So let me just open this again. Okay, so here we are going to cover each and everything that is required for Agentic AI, Gen AI, and MCP with Cloud Bootcamp. All the information you'll be able to find out in the description of this particular video. Here, our main aim is basically to show you how to build this how to use multiple frameworks like LangGraph, LangChain, Creo AI. We are also going to use different frameworks, different techniques, MCP. Everything is basically going to get covered over here. Okay. And if you are interested, just go ahead and take this. If not, yes, free sessions are obviously there, which I will be obviously covering things out there. Okay. Mohammed says that, sir, please give some discount. We are not working professionals. Hamim, just call the counseling team that is provided in the description. They will definitely help you out for the students. Okay. For students, there are good discounts that our team gives. And based on that, you can just talk to them. I don't know like what discounts are running over here. My main aim is basically to cover as much as syllabus that I can. Right? Change the edge. Which edge, sir? Anand? Yeah. Superb. Thank you. Go and check. All the information is given in the description if you want to know more about this particular batch. But this batch is something like I will be starting, we'll be talking about LangGraph, Agentic, and all. Prerequisite is that you need to know Python programming language at least. Okay. Then you're good to go ahead because here we are focusing on building applications. Okay. Sir, I have one question. Is open source LLM used in industries on production? Yes, you can use it. Okay, but again, it depends on the company's requirement whether you want to probably deploy it in the local or not. Yeah. So, how was the session overall, everyone? Good. Did you like it? Yeah. Yes or no? Yes. Can I give the prompt to give the order of execution tool? Sometimes in my query need to use two tools. Yes. Sometimes three. Yes. You can give. As you give the question, based on that, the tools call will happen. Right? Do you want me to continue this kind of live sessions, guys? Please do hit like. Obviously, that is required for my motivation. But I hope you like this particular session and you are able to understand each and everything. Okay. Yeah. Any questions that you have, I'll be happy to take it for the next 5 minutes. Yeah. Then we'll take the more live session in the later stages. I'll try to integrate something like MCP also once I get time. Will I get a recorded version of this session? Yeah, Sanjay, it will be available in YouTube in my live sessions. Can we connect LLM without frameworks? I mean, through prompts. You can do it, but using frameworks will be a best way. Okay, perfect. Guys, thank you for attending this particular session. This was it. So where can I access the source code? I will be giving in the description. There is one registration link, which you can go ahead and register. It is completely for free. LangGraph and LangChain are related or different from each other. See, LangChain is overall the company name. LangChain library is also there. LangGraph is specifically used to create more complex workflows. Okay. Okay. Perfect. So thank you, everyone. This was it. I hope you like this. Other than that, if you want to probably join any sessions, and yes, in Udemy also, if you want to buy any course, there is a coupon code April02, which you can get courses in 399. You can go ahead and refer it out. Okay. So thank you, everyone. I hope you like this particular session. This was it from my side. I'll see you all in the next session. Have a great day ahead. Thank you, and all. Take care. Bye bye. Bye bye, everybody. Okay. Will there be any session regarding modular wise on Gen AI? Yes, Melvin, we will be having as we go ahead. I'll be developing that also. Okay. Thank you. Thank you, everyone. Bye bye. Have a great day.